Now this illustration shows the branch circuit elements and components that make up a branch circuit in accordance with 422.10 A and B, as well as NEC 422.11A through G. Now notice in the NEC loop, to derate that breaker that you see in the panel board in accordance with 210.20A, we take the continuous load times 125%. We derate the loading of the breaker 80% by this method. And if you've kind of stayed with us in these other chapters, then we said we could take 1, get the reciprocal of 80%, 125. If we take 1 and get the reciprocal 125, it's 80%. So when we multiply the load by 125%, we've derated the breaker loading 80% for continuous load by applying the rules of 210.19A1A. Non-continuous load is taken 100% by the same section, but the conductor at 125% sizing derates the loading of the overcurrent device, so the sizing of the overcurrent device and the conductors are found in section 210.19A1A for sizing conductors, but 210.20A for sizing the overcurrent device, but the method used is just what I've quoted. Now, let's look at the computer load, 2 amps, non-continuous. We're saying figure 7-22A and B and figure 8-8 go into greater amount of detail, but this illustration shows the basic general requirements. Step 1, 210.19A1A, sizing conductors, and 210.20A, sizing the overcurrent device. The continuous load of 12 amps would be taken at 125%. Notice that is quoted for the lighting load. Non-continuous loads of 2 amps and 3 amps is listed for the receptacles, so that'd be 2 and 3 amps respectively. Adding those together, we come up with 20 amps. Table 310.16 says yes, if we have no derating factors involved, a number 12 conductor at 20 amps would meet Table 310.16 with the asterisk there for conductors 14, 12, and 10. Now, applying the overcurrent device, our Table 310.16, again with the asterisk, 240.4D says that number 12 is a small conductor. Table 240.4G says yes, the 20 amp overcurrent device will protect the 20 amp calculated load plus the 20 amp number 12 conductor. So in the solution, we're using MC cable with 12-2 AWG with ground conductors with an overcurrent device rated at 20 amps. So our answer and solution would match up with the requirements of 210.19A1 and 210.20A, to size these branch circuit elements to meet 422.10A and B and 422.A through G. And that's what our figure 8-17 is illustrating to the designer or the installer.